Hi, Assalamualaikum everyone. So tonight we continue the discussion on SPP Try Exam Paper 2. I have discussed Paper 1 in my previous video. So today I want to continue with Paper 2. So for today, I think I just discussed for Section A. Okay. Okay, for Section A, 60 marks. Answer all questions in this section. Okay, number 1. Diagram 1.1 shows a spoon appears bent in water due to light phenomenon. Okay, so I think you can see the clue given over here. So this phenomenon, you can see the spoon appear bent. So the phenomenon related is a refraction of light. Okay, so you must be able to relate to the phenomenon of wave in this case, which is refraction. Next, A. What is the light phenomenon in diagram number 1? You just tick one of the box here. Okay, one only. State a physical quantity that changes when light propagates from water to air. When light propagates from water to air, there is change in density. Water denser, air less dense. So as light travels from medium to another medium, which is different in density, it will bend. Okay, the bending of light is caused by change in speed. Okay, state a physical quantity. Don't state direction. The physical quantity that changes when light propagates from water to air is speed of light or velocity of light. Okay, or velocity is okay. Complete the ray diagram to show the refraction of light that occurs on the spoon in diagram 1.2. Remember, our line of vision is straight line, so we observe anything along the line of vision, so your eyes can see the image formed here. When light travels from air to water, the light ray bends. Okay, why the eye can see the image? Because the light ray from the object gets into the observer's eye. Okay, so you can draw from the object. Use ruler to draw. So this is the incident light coming from the object and then reach this point, bends away from normal, because from water to air, speed increase, so bends away and gets into the observer's eye. Line of vision straight line, so the eye can see the image which is formed along the light ray that gets into the observer's eye. Okay. So as for me, I think it's better to draw two rays. So, because normally the image formed due to light rays that intersect. Okay. Okay, so this is the second angle of incidence, bends towards normal, and then this one is 10, it will meet here. Okay, so this is the image. Okay, number 2, diagram shows a light transmitter and a photocell placed on an automatic fencing system. The gate will open if the light radiation that is directed to the photocell is blocked by the car. So you can see this one, the photocell, this one apply the photoelectric effect in the topic of quantum physics. Okay, so the photocell, so you can see the concept of light here is photoelectric effect. So you get, when a light ray or photons hit the cathode, okay, at a value of a threshold frequency, so electrons will be emitted. Okay, so we call it photoelectric effect. What is the photoelectric effect? Okay, so we can write the definition for photoelectric effect. The emission of electron from the surface of metal when photons illuminated or shone onto the surface. Okay. Or you can mention another way around. When photons is shone onto the surface of metal, electron is emitted from the surface of metal. It's okay. The threshold frequency for cathode metal is given. This is FO. The light radiation directed to cathode has a wavelength of 560 nanometer. The light radiation directed to cathode has wavelength of 560 nanometer, lambda. Calculate maximum kinetic energy of photoelectron emitted on the metal surface of the cathode. Okay, formula. Okay, what formula that we should use from here? From the photoelectric equation, photoelectric effect equation. So we have this formula. Kinetic energy equals to H FO minus okay, F minus FO. Okay, you can get the equations. The equation we have something like this. Kinetic energy equals to work function plus okay, kinetic energy. So HF is energy of photon. Threshold frequency is HFO plus so kinetic energy equals to HF minus HFO. I just want to show how we get the formula. Oh, so it becomes HF minus. Okay. F we can calculate equals to C over lambda. Okay, C is speed of light. Lambda is 560 times 10 to the power negative 9, nano prefix. Okay, so it becomes H is the Planck constant, so 6.63 10 to the power negative 54, 3 times 10 power 8 over 560 negative 9. So I erase this one. This piece. minus threshold frequency. So you calculate for this one, you will get the answer is 1.31 10 to the power negative 20 joule. So this is kinetic energy, maximum kinetic energy, EK. Okay. But see, the frequency of light radiation directed to the cathode is given, will the gate open? You look at the threshold frequency, 5.16 times 10 to the power 14. This is the threshold frequency. So for electrons to be emitted from the surface, the value of frequency of photon must equals to threshold frequency or more than the threshold frequency. Okay, so in this case, the value of F is lower than threshold frequency, so the gate will not open. Okay, will the gate open? No. Okay, because the frequency is not enough, it's smaller than threshold frequency. Okay, number 3. Diagram 3.1 shows a circuit to investigate conductivity of electronic component X. Ini kena tahulah simbol apa Kalau ingat simbol, ini adalah diode. Okay. Name the component X. You write down the name diode. Why the bulb does not light up? So look at the circuit again. As you mark direction, if the circuit is closed, okay, you can see this is P, this is N. Okay, the N type must connect to negative, the P type must connect to positive. But now it's opposite direction, so diode is reverse bias. Okay, reason is diode is reverse bias. Bincang susah. How the connection, the circuit need to be modified. So you can reverse the connection or the dual method, or reverse the terminal of battery or reverse the connection of diode. Terbalikkan diode tu supaya dia jadi forward bias. See, diagram 3.2 shows a full wave rectification circuit that consists of 4 component X. which are connected to an AC supply and cathode ray oscilloscope CRO. When CRO is switched on, the trace on screen is as shown. Nampak ni ya. Okay. Okay, full wave rectification. Complete the circuit by drawing component X in boxes A, B, C, D. You must draw diode. The input is AC current. So there's a positive and negative part. Let's say for the first positive, I mark this one as A, this one as B. We use different symbol because we have A and B here. Let's say I use P and Q. P, Q. So for the first positive, let's say current flow from P. Okay, this is the first current. Okay, so the current flow to this point, it will go through B. It cannot go to A. Yeah? Okay, if I put B, then I can draw the diode like this. This is diode B, so I want it to pass through from B, from P go to B. And then from B will go to R2. Okay. Well, because we want it to go to Q, so it will continue to go to R2. And then go to here. The current cannot go to D. This is reverse bias. This is the reverse bias level. Okay. Okay, so I1 will go here and then go down here. It cannot go to A because it cannot go back to the same terminal. So from B, it will go to R2 and then go to C. Then C is forward bias. Go to C. This is I1. And then go to R1 and to Q. Okay, so from C go to R1, then go to Q. So complete one cycle. Okay, one complete circuit. Okay, Okay, let's say we try another way of marking the direction. Let's say current flow from Q. Because alternating current, there's no fixed terminal. The terminal keep reverse every half cycle. Let's say we discuss about the negative part here. So current flow from Q. So this is I2. Okay, so go to R1. Go to R1 and then cannot go to C, go to D. Okay. Cannot go B because reverse bias. So go here, I2. This is I1. The blue color just now is I1. Okay, so I2. So means I2 also will flow to R2. Same direction as I1. Okay. And then go to here, I1. Then go to A. So means A is forward bias. Okay. A forward bias and then go to, so from D it will go to R2. From R2 it will go to A and then from A we will go to B. Okay, so we get a direction of I1 as same as I2. Okay, that's why we get here the negative part also become reverse positive. That's why we call it full wave rectification. The negative part also rectified. Okay, so this is one way of setting the arrangement of the diode, or you can also put it opposite direction also can. Okay, for example, this one become this direction, just reverse direction saja. Okay, like this. Ini pun boleh sama. Okay, part 2. A capacitor then connected parallel with R2. Sketch the trace that will be shown in CRO screen. Okay, now we have the capacitor. You can place here the capacitor. Somewhere here, you can put capacitor here. Capacitor will store charge. When current flow in the circuit, it will store charge. When current decrease or stop flowing, it will be discharged. So it means if in the circuit, if the current suddenly drop, okay, the capacitor start to discharge, means supply current to R2. Okay, as you can see from here, there's a point where suddenly the current drop to 0, then increase again. So for this part where the current decreases, the capacitor will start to discharge. So capacitor supply current. So current is not 0 when there is capacitor. Current will never become 0. Okay. So we'll draw the diagram for this one. Let's say we have the rectification graph. Initially is like this. So the trace that you observe on the screen will be like this. So if you don't want to draw the red color one, also can. So it will become this shape. Okay, but you can draw the red color one. It's just for to control the line when you draw the graph for the capacitor. Okay, ini teruskan. Okay, so it means the red color you don't see. You just observe the blue color. Okay. So capacitor is used to smooth out the output current. Okay, number 4, diagram 4.1 shows a process of nuclear reaction that takes place in nuclear reactor. This process occurs continuously. So you can see uranium bombarded by neutrons split to two, strontium and xenon. Then split to two lighter nuclei. So this one we call it fission. Okay, name the nuclear reaction nuclear fission. Okay, fission, pembelahan nukleus. Write a nuclear reaction that occurs in diagram 4.1. So just follow this one. Okay, there's a 1 neutron from here, 1, 0, N. Okay, 2, 3, 5, 92 uranium. Okay, split to 14054 xenon plus 9458 strontium plus how many neutron here? 2 neutron. 10 neutron. Okay, so both balance. Okay, the two neutrons will then collide with another uranium nucleus and then another fission continue to occur. If don't control, the next neutron will continue the fission process until uncontrollable. Okay, so large amount of heat energy will be released out. So write nuclear reaction, so just write okay, bombarded by 1 neutron. Okay, by 1 neutron, so it become 140 54 xenon plus 9456 strontium plus 2 neutron. So you can check the nuclear number both sides balance with the right side. Totalkan saja dia sama jumlah dia nuclear number and total number. So ini kita panggil equation for the nuclear fission. Table shows mass of each nuclei in atomic mass unit. And you calculate mass defect in the reaction in unit kilogram. So before and after. This is before. This is after. Okay, the mass defect, you just take mass before minus mass after. we have mass defect equals to mass after fission. We have before fission, we have the mass of uranium, which is 235.04395. Use AMU. This is for neutron, 1.00867. This is before, minus mass after fission. Okay, for the xenon, 13992.6 plus for strontium, 939154 plus 2 neutron, 2 neutron. Okay, mass of neutron, 1.00867. Okay, so you minus this one, you will get 0.19828 AMU, ataupun kita gunakan U, unit ni. So this one is not in SI unit. To calculate the mass defect, you can leave your answer AMU, but they want it in kilogram. So the relationship between 1 U and kilogram is 1 U equals to 1.66 times 10 to the power negative 27 kilogram. Okay, so we get 0.19828, convert to kilogram, multiply 1.66 and power negative 27. So you will get the answer 2.9623 times 10 to the power negative 11 joule. So answer is correct in joule. Okay, so determine the energy release. E equals to mc square. Mass defect in kilogram, and here negative 11 multiply speed of light. C, C can check the list of formula. Dalam list ada bagi. Okay, calculate this one. Mistake sikit kat sini. Sekejap. Ini ya. Saya terus kira energy habis kat sini. So mass defect tadi you convert, you can tekan capacitor, tekan sini. Okay, ini kita dapat ialah 3.29148 negative 28 kilogram sorry ya. 4. Okay, so from here okay, mass in kilogram, we multiply speed of light squared. Okay, so you get the answer in joule. Okay, the cross-sectional area of the reactor nucleus So you have the control rod, moderator, uranium rod, how the nuclear reaction in the reactor can be controlled. Okay, there are two control rods. First, to control the speed of neutron. Second, to control the chain reaction. Uh, So that's why we have two control rods. The dual control rod. Okay. For example, the boron control rod. This one is to slow down fast moving neutron. Because for the nuclear fission to occur, it requires a slow moving neutron. So need to slow down the movement of the neutron for the next fission process. Okay, so also we have a graphite moderator. Moderator untuk apa? Okay, to control chain reaction means to absorb excess neutron. Or we can say to control fission process. Because if not control, it will release out large amount of heat energy and then will cause the nuclear reactor to explode. So it's very dangerous. Okay. Here number 5, diagram 5.1 and 5.2 show two toy cars are remotely controlled using radio wave. Given f frequency of the radio wave, x is the maximum distance of radio wave emitted by transmitter that can be detected by antenna. Underline the correct answer. Okay, speed of radio wave. Radio wave is electromagnetic wave and travel with speed of light, which is 3 times 10 power meter second. Okay. The speed of light in air, same as in vacuum, also 3 times 10 power meter. Okay, thus equal. Underline the correct word. Okay, sama dengan compare frequency of radio wave emitted by transmitter, control A and control B. Okay, look at the value frequency. Means for diagram 5.1 is smaller than 5.2. Okay. The frequency in 5.1 is smaller than frequency in 5.2. Pick the correct answer. Okay, Toyka A still can be controlled even though distance 80 meters from the controller. Toyka B still can be controlled even though its distance is 80 meters from the controller. Okay, this one just can 60 meters only. This one 90. Okay, so answer is Toyka B still can be controlled even though distance 80 because it can still can be detected as the signal until 90 meters. So means for 80 meters it can be detected. Calculate the wavelength of radio wave emitted by transmitter of control A and control B. Lambda equals to V over F formula. So the speed equals to speed of light divided by the frequency from diagram 5.1. You can look at again the diagram picture. And then for B, formula yang sama. So you can see the wavelength for A and B difference. Based on your answer, state difference between wavelength of the radio wave emitted by A and B. Okay, wavelength A is longer. Boleh tampak sini calculate ni 11.11 meter. Ini 6.1 meter. Okay, relay. Frequency F and maximum distance of the radio wave can be detected by antenna from the transmitter X. Okay. The higher the frequency, the longer the distance of radio wave that can be detected. Means the relationship between F and X. Okay, from the formula, X divided by D. Lambda is B over F. Okay, so you can see the relationship between F and X. Okay, inversely proportional. In between D, F and D, directly proportional. Okay, so in this case, is F and G. Means the higher the frequency, the longer the distance between radio wave. Okay, that can be detected by from antenna from the transmitter. Phase-state relationship between frequency and wavelength. The larger the frequency, or the higher the frequency F, the shorter the wavelength. Okay, rightfully, the larger the frequency, the shorter the wavelength. So for tonight, I think I stop here because it's already 11:30. So I will continue tomorrow on number 6. So I already discussed 1 and 5 tonight. Okay, so I think I end it now. Thank you for watching. Bye.